name is Luc-Yves Pagal Vinette from Contron, Canada. So I don't want to spend too much time talking about Contron, but so this is what we're going to talk today about. OpenStack and Kubernetes powers combined for edge solutions. So it's all about disaggregated network and then what you can do to leverage both OpenStack and Kubernetes all together. So we'll talk a lot about powers and then the different possibilities around this. So let me start with this. What is Contron? So we generally, when we meet operators, they generally say con who? Well, con who. So this is Contron. So we are an innovative white box supplier. So we do something very different. We're trying to accelerate the transition towards SDN NAV. So allowing operators to actually tackle faster the possibilities around orchestration and automation. But obviously, before getting there, they need to have NAVI solutions, also white box solutions, to leverage VNFs and possibly CNFs as well. So the goal is obviously to combine proprietary solutions and open source innovation. That is the real goal, because we don't believe fundamentally that open source alone can make a difference, but the combination of the two are really relevant. Now, our key differentiators is that we have a new approach about unprecedented level of flexibility and scalability out of our boxes. So we try to decrease the footprint that is used in a cloud environment, but also to reduce fundamentally power consumption. So you can visit us at our booth with Arrow just behind, and then you can visit also our website to know more about SYMKLOUD and also Contron. So what is the power of diversity? Well, diversity is important because you need to have a certain level of portfolio in order to address multiple levels of disaggregations. First of all, if you see on the left-hand side, you see edge compute, typically MEC, multi-access edge computing device. These devices are meant to support, everything that is about, disaggregating functions and then decentralizing applications across the network. We have carrier-grade servers that are also capable of supporting NEBS, compliances, and then also the SYMKLOUD in the middle, which looks like a server, but you will see in a second it is not a server. It is more an open services platform. Then we have the top of the rack switch with the CN100, and then we kind of using the MEC platform, the M1100, as at the same time as an edge computing device, but also as a multi-VNF universal CPE. We don't fundamentally believe in virtual CPE because we believe more in scalability. If you look at VCP, this is only one device, one box. We back to the old days when you had one function, one box. We fundamentally believe in more density at the customer premises in order to support one box and multiple functions running at the same time. So this is basically what operators are doing, they did. So now if you look at disaggregated networks, what does it mean? You have multiple places when you can support applications. Data center, cloud-ready POPs, and also cell or customer side. And this is where you can leverage different kind of technology, but also different level of product. The more space and then possibilities you have to stack a lot of products, then in that case, the SYMKLOUD and the CG family will do also quite a good application of this when you have a certain level of depth available. If you look at the cloud-ready POP, you have the same level of depth, but not the same level of footprint when you can have the same level of applications. So obviously you have less applications. This is where the density is very important. And at the cell or customer side, then the depth of the rack will be different, because at the cell site, you don't have 600 millimeters, but you have 300 millimeters. So it takes different products. So in that case, for each locations, you might need different products and different also technologies like NAVI solutions that could be different. So what is the SYMKLOUD? The SYMKLOUD is the combination of server capabilities and integrated switching capability. Meaning there's two versions, the 1U version and the 2U version. The 2U version can support up to 18 servers running at the same time with integrated switching. So integrated switching can range from 1 gig to 100 gig. On the principle, when you look at the SYMKLOUD, this is the front view of the SYMKLOUD. You have the fans at the bottom and two integrated switches on the top. At the top, you have integrated switching that can work active-active or active-passive, and then you can range from 1 gig to 100 gig. And then on the switch, you have also modularity and choices because, 1 gig, 10 gig, 40 gig, 100 gig. If you look at the back, 9 service card sled can occupy the chassis. Each sled can support up to 2 servers running at the same time, meaning that, in the 2U platform, you can support up to 18 servers in the 2U platform. So regardless of the configuration, 1 gig, 100 gig switch, or 18 servers or 9 servers, the box will never consume more than 1,500 watts, making the power consumption per server at 80 watts. This is what we're talking about, decreasing fundamentally both the footprint and also the power consumption of any deployment at the DC CO or at the cloud-ready POP. So now, in terms of flexibility and choice, this is also very important because we can support data service card. The data service card can be used for virtualization and also for bare metal applications, but also video. Video for transcoding, video for CDN, and media distribution. When we can leverage at the same time Intel GPU, but also NVIDIA GPU combined with Intel CPU. So this is the last card at the bottom right. So when we can leverage at the same time Intel and NVIDIA together. So the power of density. This is what we're talking about. We can replace 36 1RU servers by 4U of equipment within a rack. Fundamentally changing the way you look at the deployment of an AVI solution, but the way you look at the deployment of telco use case. This is what we mean by the power of density. Now, the power of disaggregation. As I said, when you look at disaggregation, what does it mean really? It means decentralizing applications. You can't centralize application anymore because it will use too much your infrastructure, and you will not gain in flexibility, especially when you want to orchestrate or automate your services. What you do in that case is you have, let's say, 3 simple locations: data center, the POP, and also the customer or inode B site. At the data center, you can have the NAVO, the orchestrator, the EMS, but also the SDN controller, and you have tons of VNFs. Okay, this is where you can leverage OpenStack. You can leverage the SYMKLOUD and all the density that comes with it. Now, if you look at the cloud-ready POP, you will have less space available. Then in that case, you need the density of the SYMKLOUD. But since you have compute, you can have also applications such as the VEPC for mobile application or SD-WAN eventually, but you have less possibilities of VNFs. Nonetheless, using the density of the SYMKLOUD, it gives a good response to what you want to do. And then at the customer and inode B side, this is where you can leverage Kubernetes and Docker. Because obviously, for security reasons, you can't expose, containers on a multi-tenancy kind of approach. So obviously, you need to have some clear separation, and the separation happens not at the POP, not literally at the POP, but literally at the customer side or at the inode B side. When you have less space, less footprint in order to support application, and this is where you can see vRAN for mobile infrastructure, but also SD-WAN for typical data, applications, or any CNFs or any VNFs that could be of interest for your customer. And obviously, when we saying decentralizing application, it means as well decentralizing service intelligence. When you want to take advantage of the disaggregated network, you need to take in consideration what orchestrator and SDN controller means for you. They means everything about service intelligence, how you will orchestrate your services, or you will change on the fly your services using automation. Then in that case, you need to follow the decentralization of your applications using SDN controller and using as well, your orchestrator to be decentralized as much as the applications. So when we talk about edge service compute, we generally say, oh, this is for mobile. Not at all. When we think about disaggregation and when we think about MEC, multi-access edge computing device, we need to think about any kind of technologies that can be used at the last mile. Typically copper, fiber, DOCSIS, microwave. There's no limitation on what you can achieve. As long as you have PCI Express extension, you can do a lot of things. Even OTN, for example, optical transport network, can be eventually supported with the right interfaces. But obviously, additional elements like radio access networks for mobile can also be supported as well, and also value-added functions such as unified communications and collaborations, VoLTE for voice over LTE, and also video over LTE. And obviously, SD-WAN and managed services is part of the play. If you want to consider all the value that operators are trying to bring to the customer, it's still the same approach. They need virtual managed services in order to continue the influence on the customer, but also to increase the loyalty by bringing additional, sexy approach and new definitive approach about services. And something that is also very important is actually the possibility to leverage as well artificial intelligence, deep learning and machine learning directly at the edge level. Because fundamentally people are thinking about artificial intelligence and machine learning as only a place for DC and CO. Not at all. It can be also leveraged at the edge directly. And we can support this directly on the ME1100. The power of collaboration. This is also very important. What it means really is that you can leverage all the products that we have, from the DC, the CO, the POP, but also the custom premises. On top, you can support obviously OpenStack, Kubernetes, Docker, any NOS that are relevant to you. FDIO, it could be OpenSwitch, it could be FastPass, PCOS, there's a choice. Also Ceph for storage. Obviously OVS and DPDK can be supported. At the control layer, we mostly leverage ODL nowadays, but ONOS is not a closed door. There's always a possibility to leverage CORD, while ODL is obviously taking advantage of virtual central office. Nonetheless, ONOS is still something that is of interest. For the rest, it's obviously down to the choice of the operator to decide what they want to do. At the VNF and application layer, this is open bar. And this is what we do. We want to give the possibility to operators to do whatever they want to do with our product. What you see in there is actually a bunch of applications that could be virtual firewall, SD-WAN, anti-DDoS applications. There's no limitation. What you see as well is Cloudify. People could be really surprised to see Cloudify, but Cloudify plays a significant role not only on orchestration but also on VNFM, VNF manager. The VNF manager is there to look after the life cycle of VNFs and eventually CNF as well. So this is why Cloudify is positioned also at the VNF layer, because they bring that additional kind of layer that will be taking care of the CNF or of the VNF. And obviously at the orchestration layer, you have the choice between Tacker, Cloudify, which is a very strong, partner of us. Also, the possibility of leveraging ONAP, which is extremely important in the telco space nowadays. What does it mean now? If you look at in more details, leveraging the SYMKLOUD. The SYMKLOUD can be identified as an NAVI hardware. Then on top, you have NAVI software, OpenStack. Any release of OpenStack could be supported. We have already certified our product for Red Hat, Wind River, Canonical. We have certified as well for VMware. We're also working with NIA at the customer premises, and obviously Kubernetes and Docker can be supported. Then on the orchestration level, Juniper, Adva, Cloudify, what it means that this is still also a choice that operators have to make. Now I mentioned ODL with InnoCybe. There's no limitation to also work with Lumina networks or Sedona systems. But we have acquired recently InnoCybe. This is why I'm mentioning InnoCybe. A little bit of marketing is always good. So and obviously ONAP is obviously part of that picture that needs to be considered. Now we're reaching a point where ONAP is getting much more mature than what it was an Amsterdam release. We are now really close to Casablanca, so which will reach an additional level of maturity for ONAP. Now, what does it mean for OpenStack? It means that we have a lot of density on the SYMKLOUD. So obviously, what can we do for OpenStack? But we support OpenStack in a 2U form factor product. Generally speaking, if you go with any commodity server vendor, they will use 20U or 30U of equipment to support OpenStack. We support OpenStack into a 2U form factor. That is the difference. In a 2U product, we support OpenStack fully with all the components. Then we leverage obviously Wind River because they have a play at the DC, at the CO, but also at the edge, because they have a low footprint as well for OpenStack. Then if you look at Kubernetes, this is also the same. We can support Kubernetes, inside the box. So fully with three masters, the Docker workers, and obviously the deployment element with Mass and Juju. We typically leveraging Canonical for Kubernetes and Docker. And what is interesting there is that we can have Kubernetes and Docker running the two together on the same device, but we can also separate to take advantage of disaggregated networks to have Kubernetes running directly on the SYMKLOUD and to have Docker running at the M1100. What NIA as well plays a role in there, because when you want to leverage multiple VNF at the customer prem, then obviously you need to have a mitigation layer, a virtualization layer that will be able to sustain multiple services at once. And this is the role of what NIA plays, is actually to provide this very thin layer of virtualization that could help you to leverage either VMs or containers from the same software, software layer, and only leveraging only one Xeon core in order to make it possible. Now, if you look at the possibilities, well, the possibilities are endless. It's really down to operators to decide what they want to do with it. But most of our customers, this is what they see in the platforms, is the future-proofing of the platform to do virtual CPU, for SDN NAV, for ONAP, for virtualized networking functions, also CNFs, also for containers, but also to leveraging GPU. Now, GPU can be virtualized fundamentally in OpenStack. With Queen's release, with Rocky release, this is now possible to leverage fundamentally GPU and to support multiple workloads on the same, on the same hardware. And obviously, containers can be supported as well onto GPU. So this is the interest, to leverage CPU and GPU from Intel, but also to leverage GPU from NVIDIA. And this from the perspective of these two boxes, the SYMKLOUD 2U and the M1100. Now, let's talk a little bit about use cases. So this is typically what, I can't mention the name of the customer, but this is something that we do for multiple mobile network operators. So when they want to leverage the virtualization of a mobile infrastructure, so this is what they think about when they look at the SYMKLOUD. The SYMKLOUD can be used to combine at the same time. If you look at the top, image of the SYMKLOUD, you can see two things. The red dot, the red lines are actually for OpenStack. On the same platform, we can support OpenStack and Kubernetes combined at the same time. Then below, you have a box that is dedicated for compute. So you have compute for VNFs and compute for Docker, meaning that you can support Docker pods directly alongside VNFs, totally separated, nonetheless, on the same physical device. Then you have the top of dock switch to connect everything all together. And then if you want to disaggregate the functions, then you have the M1100 as a MEC. And if you look at the diagram, this is the way it looks like. You have on the right-hand side the central office. When you have the platform, the management platform for OpenStack and Kubernetes, you have a separate platform for compute On that compute, you can support the VIMS core, any VNFs that you want, and the CDN. And then at the cell site, you have Docker running directly on the M1100, leveraging containers with vRAN and virtual EPC. Now this is the first stage for disaggregation. If you want to go further, what does it mean? Then in that case, you look at the VEPC. The VEPC is composed of 4 components: MME, S gateway, P gateway, and HSS. You can fully disaggregate that and distribute them. Yeah, you can disaggregate them by pushing them. The MME and S gateway, you can push them directly at the cell site, and then you can push the P gateway and HSS directly at the central office. Or you can rearrange, applications in different locations as you see fit. It's actually down to operators to decide how they want to use the decentralization of application and services. But once again, leveraging Kubernetes and OpenStack at the same time, and not separately. Now, if you look at Universal CP, what does it mean? Also, once again, I can't mention the name of the customer with which we have used that. But the principle is to use, OpenStack at the CO and then to use ENIA at the customer prem. So my view of Universal CP is that if you want to leverage fully virtual CP or Universal CP, you need to also virtualize a thin layer of MPLS. So in such a case, you can use the SYMKLOUD due to the density of the SYMKLOUD. You can virtualize the P from MPLS directly on the SYMKLOUD. Then on the right-hand side, what you do, you take all the applications that are typically used by operators, the layer 2 demarcation, virtual firewall, virtual SBC for voice, and unified communication plus router. And then you virtualize everything leveraging the ENIA mitigation layer, and then you can have all your services running at the same time. So what does it mean is that you're replicating what's happening today. Yes, you're virtualizing everything, but you haven't done anything fantastic. All you have done is to put a device with a lot of VNFs, and then you're running everything at the customer prem, which is interesting because you're decreasing operational cost. You can leverage orchestration and automation, but you haven't achieved something fundamentally different. You have just virtualized some P for MPLS and then virtualize the managed services at the customer prem. That's it. But if you want to go a little bit further, what do? Then in that case, you still virtualize MPLS, but instead of virtualizing everything at the customer prem, you're only virtualizing something that is really low footprint, the router or the SD1 router. Then the rest of the bandwidth-hungry application or power-hungry application, you put them on the SYMKLOUD, where you have much more power, much more density. Then in that case, what you've done just for Universal CP is to disaggregate the network, disaggregate the functions in multiple places. And this is what you can achieve in order to take advantage for a CP that can be very, very cost-effective. You're decreasing, obviously, operational costs by leveraging as well orchestration and automation. And service density and scalability are handled not at the customer prem when you don't have a lot of space and a lot of density, but the density is leveraged directly at the CO or at the data center. And then you can manage better your perspective about new services, because we know that there will be a handful of services that can't be put at the CO or at the edge, because some application needs to be running at the customer prem. So thanks for your attention.
Thank you.